Okay, so in this video, I'm going to talk about the limit comparison test. So in our limit comparison test, we have an expression where that expression is greater than 0, and basically two expressions greater than 0. And your terms keep increasing, meaning in terms of you go from 1 to 2 to 3 to 4 to 5, okay? So that's what that all means, or at least that's how I'm interpreting that all to mean. Okay, so if you take the limit as n goes to infinity for all of these, and the ratio of the one we are given, so what's in the problem, versus something that we know how b of n behaves. So if you would get a value for that limit, they're going to behave the same. So then I have to know what happens to this one. So then if our limit equals 0 and b of n converges, so we know that this converges, the other one must also converge. So if we know this diverges, then the one that we know diverges, then this limit is also going to diverge. So let's look at our first example. I want to change my pen color. Okay, determine if this thing converges. Okay, so let's use our limit comparison test. So this is a sub n. So again, let's simplify this formula. If we were to multiply that out, multiply the denominator out, the highest power in the denominator would be n squared. The highest power on the top is 3n. So we could say this is approximately 3 over n. So this is going to be our b of n. So I just kind of simplified this function. So we then take our limit as n goes to infinity of a of n divided by 3 over n. Now simplify this out. So 3n plus 2. You're going to be getting used to doing this type of thing a whole lot because a couple of our tests all have this same idea. So again, if I were to multiply out the top, I would get a 3n squared. Multiply at the bottom, we'd also get a 3n squared. So this goes to a value of 3n squared over 3n squared. As n goes to infinity, this is going to 1. So again, we're going to some value. We're not going to 0, we're not going to infinity. So now write me a sentence. So both series behave the same by the limit comparison test. Okay. Now, tell me about what happens to this one. Three over n diverges by p series test. Therefore, of our 3n plus 2 over n plus 1 squared must also diverge. Now remember, this is different than, I just want to flip back. Okay, I didn't get the infinity. I got this case right here. So they behave the same. It wasn't this case where I got infinity and I diverged. So they behave the same, so that must also diverge. Okay, next example. So determine if this converges. So again, this is my a sub n. And again, simplify that. So we're going to compare this to the series. Take away the minus 1. 1 over 2 to the n. So then we have the limit as n goes to infinity of a sub n 1 over 2n minus 1 all over b of n, which is that. Also notice just a little notation thing. Make sure you keep writing out that limit. Okay, so again, what happens here? We really have this function, which is 2n over 2n minus 1. As I go to infinity, the minus 1 doesn't matter. The top and bottom are the same, so this is going to be 1. Behave the same. So then from here, okay, let's look and see what happens to this one. So as we go to infinity, this 1 over 2 to the n equals, look here, it's a trick. Now we have a geometric series. Okay, so with r less than 1, so our series converges. So then we have a since n equals 1 and 1 over 2 to the n converges, then this one must also converge by the limit comparison test. Okay, next example. Let's change my color again. Oh, my favorite color. We're going to use my favorite color for this one. Okay, so again, simplifying this. So let's compare this to, I don't know why, because if you take away that, take away that, because those terms don't really matter when I'm going to infinity. Now reduce your exponents, we get 2 over n squared. Okay, so now let's do our fun limit thing. Limit as n goes to infinity of our a sub n. Oh no, I shouldn't have done that. Okay, I couldn't tell what I had written there. 2n plus 1 over n cubed minus 2n all over, you know what I'm going to say? Oh no, I'm going to keep writing it. Over n squared as n goes to infinity of 2n plus 1 over n cubed minus 2n times by n squared over 2. So similar to that last problem where when we multiply all this out, we'd get the same exponent with the same coefficient on the top and bottom. So we get 1. So write me a little sentence. Series behave the same. I apologize about that. Okay. Now, compared to this guy. Okay. So since as I go to infinity, n equals 2 of 2 to the n squared. Now this is a p-series. This converges by a p-series test. Their other one must also converge by the limit comparison test. Okay? Okay. And that's the limit comparison test. I'm going to make this just one video, but keep watching through the videos for the rest of our tests. The next one's kind of a beastly test.